What's up guys, Ian Sandusky from Lakewood Machine and Tool back here again for Practical Machinist for this second very special episode of Making the Cut. Today we are actually here in France at the Walter facility in Soultz, and we're gonna get to check out some of the craziest drill manufacturing I've ever seen. Really special for you, nobody's ever got to take a camera in here before, so you're gonna get to see some stuff that no one else has. A little later on this episode, stay tuned because we're gonna be going back to Germany to their facility in Niefern, where they do PCD tipped tooling. This is gonna be a really special one for you guys. Make sure you stay tuned. Let's check it out. This is a fairly exclusive area to get into. I didn't even know if we'd be allowed. Okay guys, I'm now joined by Thomas, who is the plant manager here at this facility.
Hi Ian, nice to meet you.
And I'm joined by Sarang,
Hey Ian.
who is the drilling and turning product manager from the US, who's here to help us out and take a look at some of the things we're gonna check out. So Thomas, tell us a little bit about this facility.
So we're here in France, eastern of France, producing mainly drills. The key products are drills. Solid carbide drills is the key product what we have.
And one thing I just wanted to point out, I've had a chance to talk to a couple of the guys outside. A lot of employees you've had here have been at this facility for years.
Yes, we have every year some people with 40, 45 years working here, and it's a well-known company. People are just proud to work here, quite local and really famous for
so there's a lot of experience under one roof here. Now I believe you have some tools you'd like us to take a look at before we go check out that inner sanctum of this factory.
Yeah, let me show you.
Excellent. So this same plant produces these, which look like a hair, all the way up to something that looks like 70 times D.
Yes, it's.
And Sarang, these look familiar to me.
Yeah, these are the deep hole drills we talked about when we were back in Waukesha Tech Center for the US. That's right.
All our solid carbide drills, they have holes inside. So the particularity of these holes are some helicoidal holes. They're going through the flute towards the other side.
So those holes actually roll with the flutes the whole way down.
Right.
And that's put in there during the manufacturing process of the carbide.
That's done during the production of the rods, where they're producing those holes, and we are grinding the flute afterwards regarding these helis in the drills.
Now, as someone who has never seen how these things get made, I'm puzzled as to how some of these features can get put on there. Do you think we can take a tour through that shop and go through the process in which you make these drills?
Yes, sure.
So now we're gonna get a chance to tour this facility and see how we can go from a carbide blank right through to a finished drill. And to guide us through this, we're fortunate enough to have someone who's worked here for 15 years.
Yes.
Yannick, thank you very much for joining us today.
Nice to meet you.
Now, what do these carbide blanks look like when they start?
First, we have this. So just a bar with no particular diameter.
It's at a random length, essentially, kind of roughly cut. So what's the first thing we need to do with this before we can start machining it?
First, we're gonna grind the OD diameter.
Grind the OD geometry. So essentially, someone's gonna stick a carbide blank inside there, and that's gonna be the overall OD geometry.
Yeah, the shank diameter.
The shank geometry. How long would it take to do a part in there?
Per piece, a few seconds.
And what's the next step in the process of these tools?
After that, we're gonna grind the point on it and the chamfer.
Okay, let's take a look. So what kind of machine are we looking at here?
Here we are looking on the machine who makes the chamfer and the point.
So do you want to show me what that is?
Yeah. So the chamfer.
So that's just a chamfer in the back.
And a slot for the cooling hose. And the point.
And the point. So you can see now those coolant holes are actually exposed. And will that be the final point on the tool?
No, absolutely not.
This is just for manufacturing.
Yeah.
After they're done this, where do they go next?
We go in the next section.
Let's go take a peek.
Now we have to grind the drilling diameter.
So we've done the shank. This is actually where the flutes are going to be.
Yeah.
And this is one that's had that done. So this would be a reduced shank drill essentially. And that's done in these machines behind me. Obviously that's flood coolant all the time.
Yeah. Again, 24 for 24.
All day.
Yeah.
Now how long would it take when we're doing a drill this size to grind that diameter down roughly?
3 to 7 minutes, yeah.
And how many of these, because you guys do specials, you do production, if you were doing a drill like this, how many would you do in a run if it was a production? 100?
Yeah.
Around that?
In 8 hours, yeah. Per machine.
That's cool. So once this is done, obviously there's still, we've got the diameter down, there's still no flutes on this.
Yeah.
There's no cutting edge, there's no coating. What's the next step in the process here?
Grinding the flute.
Can we go look at grinding the flutes?
Yes.
So you guys basically use automation wherever you can here, I would assume. And those things will run, so you can set them up, it'll run for 5-6 hours overnight. Next guy comes, gets it going. And again, this is a pretty large department. You guys have, I see 6, 7, 8 of these machines all right here.
Yeah.
And this is just for your standard tooling.
Yeah.
Crazy. Now, if I'm not mistaken, these are the grinding wheels. These are the ones that go in that do the end geometry, or are these for the flutes?
These are for the flute.
These are the ones that actually will go in and grind the flutes. And it looks like you guys have shelves and shelves of these. So for each pitch, I guess you need different size, or?
Basically every pitch we have to change the wheel.
So what are we looking at here?
Here we look at the machine that makes the flute, the point, and the gash.
So this one will do all 3 of those operations in the same machine. So how do these machines actually work when they're grinding those flutes?
We have some parameters that are proper to the flute. The lead, for example, the overall geometry. And then we set up some small parameters to adapt the little difference that we can have in the same batch.
And how long would it take to be able to, let's say we're doing a drill about, the one that's in there, it looks like it's about this big by, maybe 1/4 inch. How long does it take to actually grind those flutes on there?
Basically 12 minutes.
12 minutes per. And then essentially for geometry, they're done.
Yeah.
That's crazy.
And where, if the flutes have to be polished, where is there a separate place for polishing? A separate
No,
operation?
it's done on the same machine.
Oh, it's the same machine. So right here they are getting polished as well. So for 8 times D or longer drills, we always have the flutes polished for the chips to evacuate and they don't stick to the drill. The more mirror like the finish, the easier for the chips to just, the whole point of the flutes is they get the chips out.
And that just helps make it smoother.
That's
and this thing will
exactly
actually polish those flutes in the same op.
Yeah.
Oh, so it's done when it
Yeah.
comes out of here. Wow. So where are we now? This kind of looks the same, but it's not.
Right? So it looks like this is the express production line. Express is different than standards. So standard tooling is what you get from catalog. And then there are specials. When you want a step here or different diameter, different length, so on and so forth, that's specials. Express is a very specific type of specials where you get the delivery very quick. There is hardly any human intervention, and a lot of times our sales engineers, distributors, or sometimes end users get a quote within like 15 minutes. They just fill in some diameters, lengths, whatever they need. The product is quoted to you within 15 minutes. You say, yeah, I want it. And then within few weeks,
You can get something like this. And just to show what's going on here, I take it this is after both grinding operations. So that's the rough part. And after this flute grinding, this is what we're seeing here. And this is an express special. So for instance, for somebody ordering something like this, how many would somebody order of a part like this?
Can vary between 3 or 15.
3 to 15 parts.
To 50, sorry.
To 50 parts. And again, these are solid carbide, ground custom, whatever you need. So we've seen how to make shorter tools, which obviously is a lot of work, but how do we turn something like this, a carbide like this long, into something like this? That seems a lot more challenging.
It's the same process, but we start probing the length of the tool, then we probe the coolant holes in the front, then the machine is calculating and placing the flute according to that.
Because you do have to probe those coolant holes because those
Yes.
follow the flutes, correct?
Yeah, exactly.
So if you didn't have that index correctly, you would essentially grind right through the coolant
Yeah,
holes.
that's not good.
So you literally use a probe in that machine
Yes,
to pick up those coolant holes.
exactly.
Crazy.
I will show you.
Yeah, absolutely.
Here, this is the 3D simulation in real time, and this is the probe. This little ball is going to probe the coolant holes and place the flutes according to that.
So it's just kind of like how you pick up on a mill with a probe, except way tinier.
Exactly.
So once you've picked it up, what happens next inside that machine?
So the machine is changing the wheel and placing the wheel in the grinding part, and then the process starts.
So after we take those tools off the machine, we bring them over here. What exactly is this machine?
This is to brush the point of the tool.
So what this does is this thing rotates when it runs,
Yes, it
drops down on top.
exactly, and it brushes the top of the tool, so it doesn't break as easily when it will drill.
Right, and it looks like those are a whole bunch of little V-blocks in there, so you can put pretty much any size in there.
Yes,
I have a feeling though that if you run small tools in this thing's just gonna snap it right off.
exactly. So we don't do the small one on here, we do it on this machine.
This one over here.
Yes,
We have a nice little robotic setup over here, it looks like.
yes.
I see pallets of tools.
So this is to make. This
Yep.
is done, and the robot takes the tool. It cleans it, shake it off, and put it down. And this is what is brushing the tool with a magnetic powder down here.
Oh, so that's actually using magnetic powder to do
Yes.
that same process.
Yes.
You can see it's almost at an angle and it's rotating. It's
Yes.
kind of like a Herrig fixture or something similar for a grinder.
Yes,
And that's just oil back there. So it'll dip it in there,
it's to clean the tool.
mess it around.
Yes, and it will go in this black thing to demagnetize the tool.
Oh, so that's a demagnetizer.
Yes,
So by the time this is done, that thing will be ready for coating.
exactly.
I guess the only thing we have to do is sit and put it in one of these giant things over here. What are these?
So this is to clean the tools.
This is a dishwasher for your tools.
Exactly.
And I take it, when these are loaded, you just put a whole bunch of drill bits in there.
Yes.
Yeah, but cleaning process is extremely critical. It sounds like, yeah, well, you're just cleaning off the coolant and everything, but without cleaning, if there are impurities, they're going to show up in coating. And once that impurity comes off, it's going to take the whole coating off.
Now, Sarang, this is something fairly special, I believe. This is a fairly exclusive area to get into. I didn't even know if we'd be allowed, but
Yeah,
where are
I'm
we right
surprised
now?
as well. And yeah, we are in the coating department. Coatings on drills especially is what separates the great global competitors from average drilling companies. A lot of those things are very secretive, a lot of those things are unique, patented. Walter especially is great at coatings. We not only use great global suppliers for coatings and furnaces, we tinker toy with those processes and make it our own. So we have our own special processes.
There's something new coming out you were telling me about, but I said, tell me later because I didn't understand it. Let's see if we can get through it right now.
That's the new Kratotech. Or Kratotech. That's the new coating. It's going to be the future for a lot of new drills, and it's an aluminum titanium nitride coating, and it's got 3 layers, which is a very unique process by itself, and it has a very high concentration of aluminum on the top.
And what's the advantage to that?
So it kind of, first of all, it's a very smooth surface, and it really helps with preventing the crater wear and heat. So basically, anytime you can deflect heat, you are protecting the cutting edge, and
Right.
that's what makes the tool life.
And that is done actually right here in this facility?
That is done right here in this facility. You can see some of the operators here working on putting on the sleeves. So obviously we are not going to touch the drills because these are clean batches. But what it is especially for the deep hole drills, they have to physically put them one sleeve at a time. You can see some of those drills there. The only the a little tip portion of them is sticking out, and they get coated that way, so only the tip gets coated.
So that's how we get that gold crown
That's
on
correct,
top of an
that's correct.
icon.
Yeah, that copper colored coating, that's how you get it. And the reason why we only do the tips is because, again, you remember we saw the polishing of the flutes.
Right.
And if you coat them, then the polish is gone.
Right,
So
it's
we
actually going
need-
to create sticking, but you want it
Exactly.
you want that coating on the tip.
Yeah, you want the tip to be protected for tool life, but you want the chips to go out from the polished flutes. So it's an involved process.
It's a lot of handling.
That's a lot of work. And now we are at the end of the journey. We started with the blanks, and now we went through grinding of the flutes and points and coating and everything. And the final step of the journey is laser etching the numbers. Either it's a special number or whatever the drill diameter, size, product family, all of those are laser etched. Titex logo is laser etched. And then comes the end of the journey, which is the shipping process.
And those are all
and
packaged
shipping.
by hand to make sure they aren't dropped on the floor, to make
That's
sure they ain't
right.
shocked.
That's right. Get the labels put on the boxes and all of that.
And then those are shipped to how many countries worldwide? Lots.
Rough. That's a lot. So
Expanding every day.
expanding every day.
I hope you guys enjoyed that last place, because now we have another one for you. This is Walter's facility in Niefern, where they do PCD tooling, they do customs, they do solid carbide stuff. This place looks crazy. Let's go inside and check it out.
Welcome to the Werner Schmidt plant of Walter in Niefern-Öschelbronn. My role here is the MD of that head, and we are producing PCD tools. And I think you're gonna have a look on our interesting processes today.
And there's a lot of what you guys do here is custom stuff. It is really specialty one-off type stuff.
Exactly.
This is not typical tool making.
Exactly. So this is really customized tool making here. We have 99% of special tools, and that's the challenge, but this is also the interesting thing about that factory here.
And I hear that you guys have some really crazy grinding processes that we need to check out right away.
Absolutely.
Let's go take a peek at that.
Yes.
Now, when we're talking about PCD tools, we're talking about tools that have this kind of profile. They're super, super hard PCD, which is, if I'm not wrong, that's a diamond.
Diamond, yes.
It's a manufactured diamond that is put into these cutters. But I believe it comes in like this. So how do we go from this to a tool like this?
So yes, the PCD come in like this. We will make a special program on the PC to cut the different inserts. Here it's a program for these tools. So we make it on the PC, send the program to the wire cutting machine, and we will get, if everything goes right, these different inserts.
And this stuff, I have a feeling, is very expensive. So you want to make sure you're getting the most out of every disc of PCD that you have.
Yes.
And even sometimes it looks like when you don't have, these are all the same. Sometimes you have a bunch that are different. You guys have to nest them all in the same program.
Yes. We try also to have an optimized space in the PCD program, so we have not so many scrap
Yes,
that
absolutely.
we can use for the tools.
Now, the next step to do this, we have to go to a wire EDM and go take a look at that. Do you mind showing me?
So we have here a used PCD round. We put it in a holder, and now it stays. You can take and put it in the machine. Also, we make the program at the department on the PC, send it to this machine. We have go to the start point from the program, press start, and the machine begins to cut.
And I can see right now that blue is what's already been cut. So you have two different discs on here right now.
Yes, so the blue part is already cut. The red part will cut in the night. So we have now on this machine two discs, but with the same program. So we need both 2 times.
So you'll be coming back in the morning and hopefully this will be done.
Hopefully it's done and the wire is not broken.
Because I've had that happen before as well. I run a wire EDM and that's your biggest nightmare. So once we've got our PCD cut and we have our body cut, how do we put those together?
So if we have cut the inserts, we will grind it on thickness. The inserts will cleaned in the ultrasonic and then will be brazed on the tool body.
And that's heated up with an induction coil.
Yes.
That will get very hot and that it goes in that way.
Exactly. Will be heat up. We will take out the warm one and we'll take the new insert with solder, put it in the pocket seat, heat it and press down, and then we will start to cool.
And then after that, we'll go to finishing.
After then, it goes to the sandblasting, we'll clean up, and then it goes, yes, to the wire eroding or to the lasering.
So after that's been back from brazing, it goes in this machine. What am I looking at right here?
This is a wire eroding machine. It works with a wire with a thickness normally from 0.25 millimeters, and it cuts with an erosion.
Now, that's going to actually cut the form of the PCD after it's been off the wire EDM?
Yes, exactly. The inserts were cut, brazed on the tool, and then it goes on the wire cutting machine.
And why would you
Yes.
use something like this versus something like another thing you have here, like a laser? Why would you use this or a laser?
Now in this machine is if we have the inserts are a thicker one, like above 2 millimeters, 3.2, is the wire eroding mostly faster
Okay.
than the laser machine.
The laser will actually be slower.
So the lasering have more advantages than the wire cutting. So
Right.
we can make smaller outside radius. We can go to 0.02 millimeters. At the wire eroding only to 0.1 millimeter. We can make different sorts of PCD with a good surface that we don't have on the wire cutting. So if we make other kind of PCD or a CBN, it's not the quality that we want.
Right, so if you don't want to do it here, do you mind showing me the laser we can take a look at too?
Yes.
All right, let's go
It's
see
the
it.
better one. So now on this machine we will cut, laser cut the cutting edge from the PCD tools. So we will not cut the cutting edge in one step. It be a couple of steps with different technologies.
So it's like doing step cuts almost.
Step cut, yes. step
Right.
cut. So that it's the first cut, and then we have a pre-finished cut. It goes faster and it's finer, and the end we have the finishing cut. We can use the finishing cut for tools that are ready after the lasing process. So like a milling cutter.
Yep.
We can use it, or it's pre-finished and it goes after the lasering to the grinding department to get the rest of few
Get that finish put on.
microns finished.
So we're back here in the Walter factory right now with Uwe. Nice to meet you, sir. Now, what is his role here and how did he get into that?
We are here doing the PCD grinding process, so this is pretty low tolerances, pretty detailed process, and Uwe is going to explain us what he's doing here.
Yeah, absolutely.
Uwe, kannst du uns erklären, was du hier tust?
Jawohl, wir befinden uns in der Endbearbeitung der BKD-Werkzeuge. Wir machen das Finish-Schliff, Durchmesser, Fertigbearbeitung im Mühbereich, 3 Mühbereich, nach Parametern Verjüngung, Rundschliffbreite und Durchmesser.
So I propose he's going to show us on the machine live what he's doing.
So here, I'm gonna help narrate. Can I hop back here? I'm gonna help narrate what's going on here to the best of my knowledge. That is a solid PCD tipped tool from what it looks like. And that has an integral tool holder with it as well, correct?
Right.
Now this is not new technology, if I'm incorrect.
Absolutely. So looks like it is pretty old-fashioned, but indeed this is the way to really make sure it's high precision. We're doing tolerances here around 3 microns.
3 microns. Now what's he doing right here putting on these headphones? And that's not for ear protection.
It's not for ear protection indeed. This is to better hear when the grinding wheel is touching the workpiece.
So this is literally so tight that you can't even see it. He's doing that to hear when that PCD is getting touched.
Exactly.
So what he's doing right now, I guess he's bringing that in as close as he can. And this piece right here with the red on it.
And this is exactly the noise that you hear now. And this is already the wheel a little bit touching the workpiece. This is what is the grinding.
And is that a microphone attached right there?
Yes.
So we asked earlier, and he's been doing this for 30 years. I hope I'm not throwing him off by talking right now, but this is something that takes a long time to learn.
Absolutely. And the thing is, this is not a typical profession you get educated for. This is really gathering experience by doing it.
This is and that machine does have a DRO, so it is a advanced machine, but you can see absolutely everything here is operated by hand. How many tools would he do a day in this style?
Uwe, you can tell yourself. Wie viele Werkzeuge am Tag so ungefähr kannst du schleifen als eine Person?
Durchmesser ungefähr am Tag. Circa in 10 bis 15 Minuten.
10 to 15.
So that tool right now is done.
Wir müssen erst messen jetzt.
It's about now to
Werkzeuge
check
wird jetzt
if we are really done. So this is going to the measuring, and we are going to verify if it's enough or if we have to redo it. Yeah?
So this is kind of where, I saw the machine over there, this is where the old stuff meets the new stuff, because you guys have a very advanced measuring machine over there. So this is an optical measuring machine, and what that's going to do is that's essentially building a 2D profile of that tool, so he can just visually check it and it'll give him the readout of what that is.
Exactly. So what you see here is the profile of the edge, and he's now checking if that is meeting the specification. And this is amazing to see how experienced the guys are. So the asset in making those special tools is really in the hands and in the heads of our employees.
30 years of doing this,
Yes.
that's kind of what it takes. There you have it, guys. Thank you very much for watching. This has been an absolutely incredible experience getting to travel across Germany and France to check out these production facilities and everything we got to see in episode 1. Thank you very much to Walter for having us here. Thank you very much for you guys for checking it out, and make sure you like, subscribe, and turn on notifications below to make sure you never miss a video. You take care.